Alice needs to visit the dentist. Okay, her dentist will charge $50 for the initial visit and then $35 for each of the following visits. What is the minimum and maximum number of visits she could have if she could afford to spend between $295 and $470? And we're going to want to express our answer as an inequality. So what that means is express our answer as an inequality. We could say total number of visits is somewhere between, so greater than or equal to some number, but less than or equal to some other number. And so that's what we need to fill out, the left-hand side and the right-hand side for total number of visits, and that will be our answer given as an inequality. All right, so we're looking for this. What is the minimum and maximum number of visits? So what do we know and what is unknown? Well, there's two types of visits. There's the visits that cost $50 and there's the visits that cost $35. So let's say over here, number of $50 visits and number of $35 visits. Number of $35 visits. Well, the number of $50 visits, that we know. It's $50 for the initial visit. So that only happens once. So Alice is going to pay $50 one time. And then $35 for each of the following visits. So we don't know how many of those following visits there's going to be. So that's our unknown here. So let's call that X. So there's one $50 visit and an X number of $35 visits. Okay, so let's set up our inequality. And according to the problem, the total amount of money spent has to be between $295 and $470. All right, so there's our initial inequality, but let's take that total amount of money spent and express that using algebra. Okay, so we have $295 on the low end. We have $470 on the high end. And how much is she spending? Well, she's spending $50 once plus $35 for each of the following visits. And there's X of those visits. So the total she spends is going to be $50 once plus $35 times X. Remember, X is the number of $35 visits. All right, so let's see if we could solve this for X. Looks like we're going to apply the addition rule and the multiplication rule. So we have a 50, we have a positive 50 here. So let's get rid of that with a minus 50. And whatever we do to one side, we have to do to the other sides. So we have to minus 50 from the right, and we have to minus 50 from the left. Okay, so 295 minus 50, that will be 245. In the middle, the plus 50 and the minus 50 cancel, so we're left with 35 times X. And on the right, 470 minus 50 will be 420. Right? And one last thing to do, we want to get X by itself, so we have 35 times X. The opposite of times is divide, so let's divide by 35. And whatever we do to one side, again, we do to the others. Divide by 35. Divide by 35. So, on the left, 245 divided by 35 will give us 7. The times 35 and the divide by 35 cancel, so we have X in the middle. And 420 divided by 35 will give us 12. Now we have to be careful. We can't stop here and say the answer is between 7 and 12 visits, because remember, X is not total visits. There's also that first initial visit. So X is between 7 and 12, and that's just the number of $35 visits. So if Alice pays $35 7 times, that means she has had 8 visits. The first initial visit for $50, and then 7 more visits at $35 a piece. And if she pays $35 12 times, then there's a total of 13 visits. The 12 additional follow-up visits plus the first initial visit. So it looks like Alice could go somewhere between 8 and 13 times. All right, that does it for this problem. I hope it was helpful.